Convection is a method of heat transfer that involves moving heat or energy around in fluids. Fluids can be gases or they can be liquids. A fluid is any substance, any state where the particles can move around. So oxygen, nitrogen, helium are all gases, as is Coca-Cola, acid, water, Ribena, all the particles can move there. So if we take here a beaker and we give it some particles here, the particles in here are free to move around. In fact, they're flowing around, still in contact, as per the old diagrams we used to draw. They're being a solid. The liquid are still in contact, but they're moving around, whereas the solids are vibrating and the gases are whizzing all over the place. So fluids are less ordered. They're still touching, but they can move around. Now, how this works is when I add a heat source, heating up the fluid, the particles gain kinetic energy. So they move around more, they'll be bumping into each other more, colliding more. And essentially what will happen is the fluid will expand when it heats up. This changes the volume. So if you increase the kinetic energy, we'll end up with an increase in volume. Now what this will do is affect the density. The density is calculated as the mass per volume. So the amount of stuff, the amount of matter, over the amount of space it takes up. Think of it this way. If we have a mass here of 2 arbitrary units there, and a volume of 3, when I heat this up, the amount of stuff, the amount of matter, the mass, will still stay the same, but I've increased the amount of matter that's here. So let's say I increase this to 8. So if you divide 2 by 3, that's a lot significantly bigger in density than 2 divided by 8, which is only a quarter. Okay, whereas here we're getting 0.6. So the density decreases. So if you increase the kinetic energy, you increase the volume, you therefore, wrong way around, you therefore decrease the density, which is this funky symbol rho. Now, where this becomes important in exams is drawing convection diagrams. If I have a room here and I have a heater in the corner, like so this is just a heater, the heater will heat the air above it, causing the warm air to gain kinetic energy, increase in volume and decrease in density. Now as the air moves away from here, or moves away from the heat source, it will cool down and gradually fall down, increasing in density, decreasing in volume and losing kinetic energy. Eventually it will come around to the heater again and we end up with what's called a convection current. These exist in wind is a convection current. We have convection currents in water, the Great Ocean Current. So if you've seen Finding Nemo, the Great Ocean Current, dude, with the turtles, that is a convection current. Boiling tea, boiling rice, all those sorts of things. Here's another example here. If we have an ice cube, the ice cube is going to chill out the water below it, increasing its density. So the water below the ice cube is going to drop until it gets away from the cold area of the water. Then it's going to gain heat energy from the outside, from the surroundings. So it will rise again. So this happens like in an iceberg as well. The colder water underneath it will be less dense, and the warmer water away from it will form convection currents. Okay, so convection is movement in fluids of energy. So these little particles here will get less dense and rise, carrying energy with them.